Okay. So contingency table refers to qualitative variables. So here, right. There's one variable, variable one, several levels, variable two, several levels. It can be variable one, can be like ethnicity. This can be like smoking status, whatever it is, right? Two variables, huh? Don't, I mean, just see what it is, but SPSS is going to table the two things for you later. Basically, look at the chi-square. There's a chi-square. Basically, you want to know whether association. Look at the chi-square. Is it big or small? Then you make conclusion. I don't want to go details of the formula. Example here. Is there an association between physical activity and obesity? Physical activity versus obesity. Physical activity, is it qualitative? Is it qualitative?
Yes.
Type exercise. Obesity, is it qualitative?
Quantitative.
But they already categorized, right? Isn't it?
Yes.
It should become ordinal data. So it's no more quantitative. So both are qualitative data. So follow this instruction. Very simple, straightforward analysis. PA versus obesity. Physical activity versus obesity. Earlier, we are done for testing of means, physical activity, and BMI. So from BMI, we convert to obesity, yes, no, physical activity. Then click these two buttons, statistics and cells, statistics chi-square, cells row percentage. All right. So statistics chi-square. Click this, cell row percentage. Again, put in PA, obese, click statistics. You do this and go back, click cells, you do row percentage. Next, click OK, the results comes up. What's my objective? Then association between physical activity and obesity. Example, those who are active, are they less likely to be obese compared to those who are not, right? So this 33, what is 33 denoting? What is this 33, number 33?
33% of the total participant.
The correlation.
All right, this 33 refers to what?
The sum of obese and normal.
No, this rarely, how many rarely exercise? Isn't it? This row, this rarely, right? Plus, add up 24 plus 9, 33. In this sample, 33 people rarely exercise, correct?
Yes.
Next one. What is this 27?
21 plus 27 people sometimes exercise.
What is this 48?
48 people regularly exercise.
Right, this is a total margin, okay? Margin. To come this way, what is 57?
57 obese under the total.
Right. 51? Normal.
Normal.
Right. So now I can say in this particular sample, 57 or 52.8% were obese, 47.2% are normal. Among the sample, 33 rarely exercise, 27 sometimes, and 48 regularly. But my objective is PA and obesity, are they associated? Look at the p-value. So what's the p-value here? Is it less than 0.05?
Yes.
That means there is an association. P-value more than 0.05, we say no association. Right, the p-value, you're asking whether PA, obesity, are they associated? All right. Jeffrey asked me the question. What do you want to know? Jeffrey, you asked me a question. What do you want to know?
So how many percent?
No. Are these two associated, right?
Yeah, how?
No. You asked me a question. Are these two associated?
PA obesity associated.
Associated. Yes. What's the next question?
How many?
How much does
How? Direct.
How? Yeah.
How? So look
How
at the table now. Look at the table. Among those rally, 24 over 33, that is 72% obese, right?
Yes.
Among those, it's likely rarely 72.7% obese. Next, sometimes, how many percent obese?
77.
Obese. Regularly,
Only 25.
only 25. So p-value less than 0.05, then association, yes. How? Only 25% of those exercise regularly or obese compared to those exercise only sometimes or rarely. Compared to, okay, compared to more than, can I say 75%? 70%, right?
20.
Among those who exercise only sometimes or rarely. Is it like 3 times more? Is it 3 times more?
Yes.
Right. Those regularly only 25%. Rarely and sometimes about 75%.
Yeah.
So those exercise rarely and sometimes about 3 times more likely to be obese, right? Is that right?
Yes.
This 25, this about 77, about 3 times, right?
Yes.
So we run the analysis, look at the p-value, conclusion, there is an association. How? We look at the percentages here. Among those regularly, only 25%. Among those rarely, sometimes more than 70%. That's one assumption here. Look below the table, the minimum expected count here, 12.75. For a sample size of more than 100, this must be at least 1. If not, some cells are empty here, then it record. We see any example later, okay? All right. Second example. Between job category and movie type. Job category and movie type. Right? Eva, what do you want to know?
If they are associated
Between?
to the job category and the movie type.
Right. What's the p-value?
The-
Is it more than 0.05?
Yes.
Therefore, there's no association. You ask me a question, is there an association? My answer, there's no association. What's the next question?
No more questions.
No more questions. Right. Look at this now.
End of question.
Action, attendance 42, 41, but 36, not much a difference. This romance, 33, 30, 33, 39, not much a difference. Here also not much a difference. The p-value is more than 0.05, no association. And the expected count is more than 1, assumption is okay. So whenever the p-value is less than 0.05, at least one group will differ from others. Same like one way another, p-value less than 0.05, at least one pair differ. Here p-value more than 0.05, we say no difference. So job category, movie type are not associated. Very simple, straightforward analysis, right? So that's a value. All right. Okay, let's do some exercise on this. First do this example first, then exercise. We're going to do all this. Okay. Let's do, it's a very simple, straightforward analysis. Let's do example 1. The same data set 1, we done so many analysis. So follow the instruction, analyze, descriptive, cross-tab,
Steps.
right? Analyze, descriptive, cross-tab. Row, PA, column, or B's. Right, it's a hard pass rule, what goes where? There's no such thing. But normally, what came first, go to the row, what come later, go to the column. What came first, physical activity or obesity? What do you think came first, physical activity or obesity?
PA come first.
Huh?
According to the statement.
Okay, no, generally asking you, logically. PA first or obesity first?
A.
Obese because of PA or vice versa? They're obese because lack of physical activity, or lack physical activity because of obese.
Lack of physical activity.
Okay,
Because
so
of
normally that's how we decide, but not necessarily. Can be other way around.
Okay.
It can be column or row. Practice normally what came first, you put in the row. Because of that, obese put in the column. Right. Next, statistics. Click statistics. So in statistics, ask for chi-square. Continue. Go to cells. So in cells, we ask for row percentage. Row meaning physical activity rarely how many percent are obese. So it's a row percentage. Follow this criteria. Continue. That's all. Click OK. These are the tables. Physical activity, obesity. Yes, there's an association. How? About 75% are obese here compared to only about 25%. The assumption, minimum expected count, more than 1, the assumption is met.
Professor, I still don't understand very clear about this 12.75.
Okay,
Expected count.
12.75. So where the value came from, right? Okay, let me show you where the value is. Okay. This value is expected count. Did you see expected count here? So this value, how do you get the value? 33 row percentage multiply by column percentage.
Oh,
37 times 33
yes.
divide by total.
Okay.
33 row percentage, row number times column number divide by the total. That is 17.7%.
Okay.
So where is the 12 point something? Where is 12.75? 12.75? This one, right? This one is right? That's the minimum value, right? Class the 12.75, that's the value, right?
Yeah.
Right. So
Okay.
let's say now, this for obese, physical activity obese. Supposing I just create one more group, right? Just to show what it means by minimum expected count, KPA. So this level 4 for some reason, different level. If I do the analysis now, what's the minimum expected count?
1.
Is it less than 1?
Yes.
That means even though significant, the results not valid. Why? So look at this table now. for this group 4, how many entry here?
Only one.
Only one. The 1 will go into the first cell or second cell, right? The 1 will go into obese or normal, right? So this is 0, right?
Yes, so
That's why the count is very low, 0.45. It can be typo, right?
Yeah.
Let's say it's not typo. It is a value. Anybody do? Either merge it with some other cells or delete it
okay.
and repeat. Now, is the count okay? Is the count?
Yes.
Yes,
Yes.
it is valid. But earlier, even though significant, the results not valid. That's why it's category 4, only one value.
Right.
Either we combine with another group if we can, otherwise remove it. You okay?
Okay.
Are you okay? What does it mean? Very few in this group, isn't it?
Yes.
So here, what it says here, under group 4, 100% obese, right?
Yeah.
I mean, how can I say take 1%, 100% obese? You take 1%, it'll be here or here, right?
Yeah.
So happen here, 100%. To say that category 4, 100% obese is not enough evidence, only 1%.
Right.
You drop the group and then redo. So now the assumption is met.
Okay.
All
Yeah.
right? So that's the idea.
Okay.
If it's rare, but it's possible. It might happen.
Prof, just a quick question here.
Ah.
In case we are conducting a small survey, just like maybe the sample size only 20 like that, is that will be a chance having this type of issue?
Very high. So normally, a small sample size, try to take only 2 by 2. Example here, diabetics and hypercholesteremia. Is it 2 by 2?
Yes, no, yes, no.
No, yes, no, right? If you do 2 by 2, just watch, huh? Okay, cross tab. Let's say any association diabetic is hypertension, all right? Diabetic hypertension. People are diabetic are also hypertensive or not, right? Cells. Okay. Is the count okay? Is the count okay?
Yes.
Supposing it's not. Supposing only small sample. Example, let me take a small sample of this now. Let's say I take only 10 cases. What variable is that?
Hypertension.
Okay, ideal, right? It's a very small sample. I do the analysis. Right. When it's a small sample, see, very small, right? Only 50 members, right? Correct?
Okay.
So when you 2 by 2, it's one more column opens up. Exact test. So small sample actually below 60 here, don't refer to this p-value. Small sample, you refer to exact test. So what's the p-value here? Is that less than 0.05? Therefore, we say no association. So small sample, don't use this p-value. Make sure it's 2 by 2, and then take this p-value. Do one more example, whether DM and obesity. Are they both 2 by 2? DM yes, no, obese yes, no. The result will be 2 by 2 table. Why 2? 2 levels, 2 levels. Sample size very small. So refer to exact test. Sometimes it's possible you may have this situation. Cell count's very small. That's not valid. Then what do you do? Maybe you collapse these two, combine these two. There's no exact test here. Exact test only for 2 by 2. The exact test only for 2 by 2. Small sample sizes, preferably bring them to 2 by 2. Rarely sometimes add together, regularly by itself. Are you okay? Are you okay?
Yes.
Right. So that's how you handle small sample sizes. Bring down to 2 by 2.
So normally the expect mean they will come up with columns, right? The test.
Currently, this result, is it valid? Supposing significant, okay. Is it valid? Small count, very small, right?
Yes.
So you have to do something. Maybe collapse. I'm going to collapse these two. Rarely, sometimes together, okay?
Okay.
Right, rarely or sometime, I think 1 and 2. Transform. What is that? PA. That's PA. Okay, PA. Let's say I put 1 become 2. Collapsing. I'm collapsing these two together. All right. I repeat the analysis. Has it become 2 by 2?
Yes.
2 by 2, we have this value, right?
Okay.
This value is 36. This is not. So when small sample, try to bring down to 2 by 2. Especially clinical assessment, lab test, we cannot afford large sample size. But field study, we can afford large sample size, so what you won't have these kind of situations. Are you okay?
What is the minimum percentage for it to be valid?
Okay, first, this must be more than 1, okay? And then secondly, if the total sample size is less than 60, maintain only 2 by 2. Just now, this is 3 by 2, only 15 cases. The results, this result not very good, not valid. Furthermore, you can see this count. So I collapse this 2. I collapse this 2, I have this 36. I refer to Fisher's exact test. Called Fisher's exact test. Are you okay? Who asked the question? Are you okay? Who asked the question just now?
Yes, okay.
What's your name?
Jane,
What research are you doing?
the pap smear.
Pap smear. So yours can be a small sample, right?
Yes.
So you try to use this. But it must be 2 by 2, okay?
Okay.
Example, this material 1, material 2. This success, failure, right?
Yes.
And then you can use this. So most of the time, small sample statistics in the biomedical area, we do the Fisher's exact test.
Okay.
Because some of the trials can be very expensive. All right. Clear?
Yes, clear.
Let's summarize this. Summarize what I've done so far. Okay. Variables. Okay, variable 1. Variable 1, 2 variables. All the while, you're talking about 2 variables only. Variable 2. when both variables, these two variables, one is quantitative, other one's qualitative. Qualitative, right? Quantity and quali. Example, gender. Sorry, gender and BP. That side, huh? This is BP. This is gender. Gender, how many levels? How many levels are here?
2.
Two levels.
Two levels. Right? So variable one, quantitative, you put below here. Right. This quantitative, this qualitative. So we do, the test will be t-test. Right? T-test, independent sample t-test. Or the variance not equal, many u, right? Non-parametric. Quantitative versus qualitative, 2 levels. So what if, again, one's quantitative, other one's qualitative, but here, like physical activity, more than 2 levels. Correct?
Yes.
Physical activity. Then what test? ANOVA
Number.
or classical Wallis test. Non-parametric. So what if both are quantitative? Both are quantitative, right? Okay, this quantity is also quantity. Then what do you do? We do correlation and or regression. What if both are qualitative? Example, physical activity and obesity, right? Obesity and physical activity. Doesn't matter how many levels. So this will be, yeah. Yes? Somebody call me? Okay. So talking variable one, variable two, what test use? Last one here, this will be crosstab followed by chi-square. Chi-square test. Again, this all we did, correct? T-test, ANOVA, correlation regression, crosstab, chi-square. That's all we did so far, 4 classes.
Yes.
Right. So when do you use the first one, t-test? T-test, when do you use it?
You have one variable from quantitative, one variable from qualitative.
And 2 levels, right? This is this. Second, quantity, quali more than 2 levels, ANOVA. Both the quantity, correlation regression. Both the quali, crosstab and chi-square. Right? The test is chi-square test, huh? You shouldn't use crosstab, chi-square. Right? Chi-square test. So these are tests. These are called the basic statistical analysis. Sometimes call them diploma level statistics. Are you diploma level?
No.
No.
Right. Are you diploma level? You may be PhD, but when it comes to statistics, you are still
Diploma level.
statistics. But why must I teach you diploma level? Must I teach you degree level, postgraduate level, right?
to get the concept, the basic.
That basic. You understand what's a p-value, what's a variable, what test. Later,
So,
we'll,
Professor,
yeah,
so this say this variable 1 and variable 2. This is only one simple linear.
bivariate, only two. All, whatever I did so far, only two, right?
Yeah.
Isn't it? It has two
Yes.
variables, one quantity, one quality. Another two variables, again, one quantity, one quality, two levels. We did BMI and SBP. We did obesity and PA. Only two variables, right?
Yeah.
In real life, things don't work this way.
Yes,
In
correct.
real life, in real life, the BP may depend on so many factors, right?
Yes.
Example, age comes in. Age comes in, no more simple. We call multiple linear regression. This is simple linear regression. So whatever you're doing here, you won't be using at all, mostly, unless lab test, okay? Lab experiments. Just now somebody asked, when I use cross-type? Maybe yes, small sample. But most of the time, it's a population-based study, right? Nothing of this sort. So next week onwards, we're going to multivariate analysis. From here, move on to multivariate. Multi means what?
More than one.
More than two.
More than one predictor. No, multivariate more than one predictor. Supposing it does BP depend on gender. Only one variable, right? Here, one predictor. One predictor. So we know that one predictor. Things may not work one-to-one. There could be more than one variables. So multivariate. That's what you need for your master's or PhD. Are we clear? Yeah.
Professor, so because today is already 7th of September,
Hmm.
so we have another 3 classes, right?
Yeah.
So so that means for next week onward will be all multiple regression.
Multivariate, huh? What are you going to do
Multivariate.
is multiple linear regression. Multiple linear regression. The 2 general linear models. The 3 logistic regression. And one more will be factor analysis. Right. So these are 4 things you're going to do.
Okay.
Unfortunately, can't do partial least square and structural equation modeling there because the software is not available for you. So you're going to do these are the multivariate analysis. All extension of this at more detail. So multivariate analysis. So once you finish this, there'll be one more assignment. Once you finish these 2, one more assignment. And this last assignment. Clear?
Yep.
Okay. So let's go.
Sir,
Yeah.
so what is the format of our final examination?
There's no final, all by assignment, 4 assignments.
4 assignments?
4 assignments.
Okay.
25% each.
So we still have 3 assignments.
Yes. 3 more assignments.
Okay.
All right. So that is very clear with this. Next, we're going to move into this next week. So
Okay.
far, our assignment 1 was this, right? Isn't it?
Yes.
Assignment was this, right? So later, we do more of the assignments. Maybe after that, go to multivariate assignments on this. Let's see how to present this. We're done. How to present this output. How to present this. Let's see how to do this. We're done. How to present the results from t-test, from ANOVA, whether parametric or non-parametric. Just now I've seen how to present these results. Let's see how to do this now. All right, let's go back to your data. Let me select all. All right. Now, our variable of interest, let's say, what is in your file? Eh? Okay. Hypertension versus all these variables. Hypertension, is it qualitative?
Yes.
Are these also qualitative?
Yes.
Yes. Therefore, we do cross tab. Okay. Analyze, descriptive, cross tab. The outcome of variable is hypertension. So bring in hypertension. The predictor variables, you can put all in one go. You don't have to do one at a time. Job category, obesity, physical activity. Now I have only 2 levels, I recorded just now. Physical activity and diabetes. So all these can be analyzed just one go. T-test and ANOVA, we do one at a time. Still univariate, right? So statistics, chi-square done. Cells, row percentage. Click OK.
Sorry, now you choose the percentage, correct?
Now row percentage.
Low percentage, okay.
Here I chose under cells.
Yeah.
Let's choose this, take it out. Row percentage. This is a row,
Oh.
right?
Yes, 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 yes.
Right. So this is a row, sorry. Oh, sorry. Other way around. Other way around. Eh? This is the row. And that's a column.
Oh, okay.
Right. Among the gender, how many percent are hypertensive and so on. That's okay, row percentage. Okay. Now, first table for gender, second table for hypertension, sorry, second table for category, third table for physical activity, now only 2 levels, I just not recorded. And then diabetes, obesity, right? So how to present this now? We're going to create a table like what I did earlier. Okay. Okay, that's my demography, right? Gender and everything. So okay, more or less you're going to use this. So we use the mean, testing means, or the, what is that, medians, huh? We use ANOVA, t-test, cluster values, or Mann-Whitney. So now we're going to use, okay, let's say I take this table. Okay. What's the objective here? What could be the objective?
Determine the hypertension in the population.
Again?
Determine the hypertension in the population and the factors associated.
The objective, determine the, say, just now was SBP, right? Isn't it?
Yes.
Now it's going to be categorized into hypertension. We call it prevalence of, I put HPT, hypertension, among hospital staff and the associated factors. So determine the prevalence of hypertension in the population and determine the factors associated with hypertension. Okay, so here we add one more column. So this will be Yes. It will be no. And that's a p-value. So you want to say among the male, female, how many percent are hypertensive and so on. So title will be comparison of hypertension by all these variables. We done the analysis already. Gender. Right. Female. So here is going to be number and percentage. Number and percentage. Right. Is small n, okay? Okay, female, how many number of this? 41. Female, 41, 71.9%. Next one. Among male,
10,
10.
19.6.
How many percent?
19.6.
Next. 16.
16, 20.
8.1%. Next. 41. 80.4%. So what's the p-value? Is it less than 0.05?
Yes.
Yes, less than 0.05. What about the assumption? Is it met? The minimum count? Is it more than 1?
Yes.
Sample size more than 100? More than 1. Is sample size small? Ignore the p-value here. Is it 2 by 2?
Yes.
Right.
Yeah.
Small sample size, then you take this value. But here, large sample size can still refer to this value. All right, so what do you see now? Factors associated with hypertension. The gender associated with hypertension? Is there an association between gender and hypertension?
Yes.
P-value, yes, right?
Yes.
Right? How does it work? Who's more likely to be hypertensive?
Female.
Female.
Right? So this is hypertension, it's between, this is no hypertension. When you say there is an association, what's the next question? Is there an association? Yes. What's the next question?
How are they associated?
Huh?
How are they associated?
How? 71.9% of females are hypertensive compared to only about 19% among the males, right? Correct?
Yes.
Yes.
I mean 19% of the males are hypertensive compared to 72% among the females, right? So females are more likely to be hypertensive.
Is it true?
This is just a data, right? It's not a real life data, okay? All cooked up to show how to analyze it, how to report it, okay? All right.
Okay.
That's why I say this analysis is very dangerous. Why?
Hypertension.
Why? It's not gender alone. Other factors may be important, right?
Yes.
Work nature
Yes.
may be important, right?
Yeah.
What years of work is important. Physical activity is important, right? Marital, is it important? Hypertension,
So-
marital status? Possible?
Yes.
Possible. So we think gender makes a difference. So this analysis must be taken cautiously, okay? That's why next week going to multivariate, how all the variables collectively act upon this. But time being, because you're doing diploma level statistics, right?
Yes.
All right, diploma level statistics. So just keep to this first. All right, let me use this data, these variables. Okay, let me use these variables, huh? Let me do again. Okay, what are the variables here? Gender, job category, PA, diabetes not, obese is not, marital status. It's all right. Years of working. Come years of work, years of service. Right. So we did statistics, chi-square, cells, row percentage. All right. So then the first one. Second, is there an association? Is there an association?
Yes.
Yes. So job category p-value is 0.001. Is it less than 0.05?
Yes.
Yes. So how does it work? How does it work? Who's more hypertensive? Nurses, right?
Yes.
So doctor, how many of them are hypertensive? 11. How many percent? 3%. Nurses, 26. That is 72.2%. Next. Next.
14.
14. 50%.
35.9%.
35.9%. Okay, you fill up the side here. All right. So significant among the female, 7 nurses, right? Among nurses, 72% hypertensive compared to only 33% among the doctors and 35% among the attendants, right? Isn't it?
Yeah.
So more nurses are hypertensive. These nurses, are they mostly females?
Yeah.
Female.
So what made a difference? Gender made a difference or job category made a difference? What's the answer?
Don't know. We
Go.
Okay.
We don't know. That's why we must go to multivariate. We must correct for each other. Right, next we'll see how it works. Right, years of working. Years of working. Is this significant?
No.
No.
No, 0.112. Must you fill up these values here? Yeah, they'll fill up.
Sorry.
The table empty, right? 45.5% and so on. Look at these percentages. According to the calculation, it says these percentages are not much difference. Compare this 45, 57, 33 versus 3, 33, 72, and 75. This is very much higher than this. Others, right? So fill up. Next, physical activity. Unfortunately, I need 2 levels. I recorded just now. Physical activity. Is this significant? Is this significant?
No.
No what? What's the p-value?
Yes. 0.0.
More than 0.5.
Huh? This value?
Less than 0.05.
Oh,
0.0.
not significant.
0.01, right?
0.1.
0.0.
0.1.
Is it less than 0.05?
Yes.
Yes. How does it work? First one, 35, 58.3. Next one, 16, 33.3. So what's the connection now? Among those who exercise regularly, only 33% hypertensive compared to almost double, right?
Yep.
Right? Almost double compared to regularly hypertensive. Okay, marital status. Is this significant? Is this significant? Marital?
No.
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 Marital p-value is 0.075, which is more than 0.05. So it's not significant. The first question, what's the prevalence of hypertension? First question, you do a frequency, right? So go to analyze, descriptive frequencies. So bring hypertension, what percentage are hypertensive? What percent hypertensive? 47.2%, right? Correct enough?
Yes.
Right. In the sample 42 point, sorry, 51, bracket 40, 41, 7.2%. Were hypertensive. This is a sample statistics. But what can you say about population? We need a 95% confidence interval. How to get this? It's a bit tricky. We use a formula, calculate manually. But if I code this 10, currently, this observer, currently my hypertension 12. I'm going to code this one here 10. I'm going to recode the 2 become 0. A small trick, okay, how to get that value. The 2 I label as 0. Can I do frequency now? Are we having the same value? Yes, 47.2%, right?
Yes.
Right. Now my coding is 1 and 0. Approximately, we can do the inference in the explore procedure by taking this value as hypertension. That's hypertension. Okay. When I label 10, that becomes your 95% confidence interval. I take 10, the mean is actually percentage, right? Plus, when I take 10, the mean is actually percentage, right? Let's say 70 males coded as 1, 30 females coded as 0. What's the mean? 70 males coded as 1, 30 females coded as 0. So what's the mean value? 70 males and 30 females. Males are coded as 1, females are coded as 0. So this times this, 70, right?
Yes.
This times this, 0, right? And add them up is 70, isn't it?
Yes.
70 out of 100, right? How much 70 over 100?
70%.
70%. So I'm making use of this 10 coding. You can't use 12. It must be 10.
Okay.
Right? You will show it here, okay? This times this. And then we add it up. Sum of these two. Then average it with this value, divide by total. If I coded this as 2, 1, 2, what happens? 1.3, 130% is meaningless, right?
Yes.
If I code this 0, then this will be 70%, right?
Yeah.
Right. I'm using that particular advantage, but only approximation. The sample size large is quite reasonable. Okay. So what's the 95% confidence interval? What's the 95% confidence interval? Prevalence of hypertension 57.2%, 95%, 95% CI. What's the interval?
Recording in progress.
37.7% to 56.8%. That's the answer for number one. Prevalence of hypertension can be anywhere between these two. Right? So later, as I say, you must have your objective very clearly stated. So this only sample value. This is an estimation for the population. Okay, that's for objective number one. Objective number two, determine the factors associated with hypertension. Right. So what test used? In testing factors associated with hypertension. What analysis was used? Chi-square test was used. Okay, let's call it table 2 or table 3. So what's the conclusion? Among the tested variable, which is significant? Which is significant?
Gender, job category.
Gender, job category,
And physical activity. Yeah.
were significantly associated with hypertension. Can I explain how males among the, in terms of gender, 71.9% of the females were hypertensive compared to only males 70%, 19.6% among the males. So explain whatever significant. So I don't have to explain this because I'm talking about among the tested variables, right? Among the tested variables. If these are significant, you can explain, right? You want to put the p-value is fine. P less than 0.001 to make it complete. So this is all expected out of you. Later when you do your thesis, right, or project paper, whatever it is. PA, how many percent? What's the p-value? According to mine, okay? P equals to
0.01.
0.10. Yeah. 3 decimals for p-value. Right? Are we clear?
Yep.
All right. So I'm going to give another exercise. It's not necessarily you must submit or not, it's up to you. Objective, I want something like this. So here, we refer to customer data. So determine the price. I think only the same thing. You do this for obesity. That's one variable, obesity. So change this to obesity. All the rest remain the same. How do they connect to obesity? Right? So here, the objective will be prevalence of obesity. And right, and the factors associated. So first one will be prevalence of obesity. Next one, factors associated with obesity. So do exactly what I've done for your exercise. As Jeffrey said, more you exercise, better you become. So do exactly what I did just now. Complete the table and make your conclusion. Are we clear on this?
Yes. So that means we need to do the 2 exercise from the other one and plus this one, right?
If you want to submit. If you want to submit, it's okay. So this is not compulsory to submit, just for your exercise.
Okay.
Okay, don't submit this, okay? Don't submit this. Only
Okay.
for your exercise.
Okay.
This one, no need to submit. Make life easier, right? For you and for me, right?
Thank you.
So that means you don't have to do, right?
No, I will do it because of the system always very clumsy.
Okay. All right. This one no need to submit for you to practice.
Okay.
Right, but give us an assignment, you must know how to do it. So don't copy and paste from your SPS output. Imagine a copy and paste what will happen here. Right? We have copied and pasted all the tables. Right? This is what some students do. Straight away, fail. Copy all these and paste there. So what are you doing? What are you telling us? You're telling us you know how to do the SPS work, but don't know how to summarize it.
Right.
The objective is this, not to show me the SPS tables. So summarize. One table I know what makes a difference. That's all I want to know. We still want to hold on to the output, put them in the appendix. Are we clear? So in future, I want the assignment must be straight to the focus here. What's the objective, right? And then accordingly, what analysis, report, summary, finish. Okay.
Professor, also I have to ask, for example, the assignment, I think it's better you give us the word limit.
No word limit. No
because
word limit.
you can elaborate a lot of things. So
no word limit. It can be just one page.
Okay.
I know you explain how it works. That's not my objective, okay?
Okay.
That's a discussion.
Okay.
Right? Mine is just asking the analysis, determine the factors. Determine the factors, I will say gender differ, males are higher. I'm not asking you go to literature and find out why males are higher. That is chapter 5, your discussion. We are still chapter 4. Just tell me what percentage males, females, that's all.
So I mean, in the future, the assignment, the other 3 also 1 page, right?
Very simple, straightforward. Chapter 4, the results. Right? Later when you do your thesis, there'll be chapter 5 later. You take this and discuss. What I mean by this is, I'll take this. So I summarize it here. I take this and I go to chapter 5. Right? Another part, right? The chapter 5. Discussion. Right? I put it here. Tested variables. We don't need the p-values. right?
Yeah.
Need this was significant. Then we explain why. This is backed by literature. Currently, I didn't do any literature. I'm just taking the variables and testing how they make a difference, right?
Yeah.
Isn't it? And
Yes.
then go and search literature, explain why gender makes a difference, why job category make a difference, and then you expand it. So these are just the things I summarize in chapter 4, bring it to chapter 5, easier to explain, right? All this part, focus on my objective, right? Correct?
Yes.
Objective 1 is prevalence. So prevalence number 1. So prevalence, is it high? Is this prevalence high or normal? My first objective was the prevalence. Is it high or is it normal? Where is it? 125. Okay. If I go to the prevalence of so much, is it high? That's where literature comes in. You compare this a national value. The national figure, suppose the national figure is only 20%. National
Yeah.
prevalence only 20%. So discussion now, is it very high?
Yes.
Yes. That's where discussion comes in.
Mm.
I don't have to tell in our assignments. You want to do something? Okay, fine. But that's not your project work. It's not your thesis, right?
Yeah.
Later in a thesis, after this, you discuss that higher or lower compared to general population. All right. Any questions?
Yes, Professor, I have a question about table 3. Would you please show us the table 3?
Table 3. Let me close all this like where the table is. The table.
In the exercise.
Is it this one?
Uh,
Is it regression or?
no, it's about the significance. But my question is, should we report the p-value of Fisher's exact test if there are 2 levels for each variable?
No,
For instance, gender, female and male. And so the p-value, should we choose the p-value of the Fisher's exact test or the significance of a symbiotic significance?
To mention this. There were 108 respondents in the sample. All right? You clear this already. That means a normal without Fisher exact test is fine. You're mentioning 108 respondents, right? Supposing only 10 respondents, then all this must be on Fisher's exact test. Right? That will be p-value of Fisher's exact test. This statement is very important. Only 10, we use the normal chi-square, then you say results not valid. Right? Only 10, Fisher exact test will apply for this, not for this, right? Maybe attendant and nurse collapse it. Possible? Maybe years of working, maybe I collapse these two into less than 10 years. Here, maybe I take married and not married. Then all 2 by 2, right? All right. Sample size only 10. So this all be Fisher exact test.
So if the sample size is very small, we use the p-value of Fisher's exact test.
As you stated here, my sample size is very small.
I see. Thank you.
Okay. Questions? No question?
Teacher, I have a question.
Ah,
Because last class you give us the access one, but I don't finish it. So could you give more time
okay, Saturday. By Saturday,
to submit the access as one, right?
I'll give you until Saturday. Is it okay? Saturday.
Okay.
All right. Okay. Is it enough for today?
Yes.
Yeah. What have we covered so far?
Have homework today?
What have we covered so far on the 4 weeks?
Diploma level.
Diploma level statistics. So next 3 weeks are very important. All right? We go into this. To understand this, these concepts are very important. All right? So I'll send the notes for next week. And you are using the same Zoom link. All right?
Yeah.
Okay. Good night.
Thank you, Prof.
Bye.
Thank you,
Yeah.
Professor.
Bye.
Thank you.
Thanks, Prof.
Thank you, sir.
Bye.
Bye.
Bye.